real exam questions. This is about question 20. It deals with beam design. Consider a beam placed in a brick wall, a bearing brick wall, and this is during a renovation work. And you can consider the beam as an isostatic beam on two supports with an effective span of 4.07 meters. And the characteristic value of the uniform distributed load is 22 kilonewton per meter. It includes self-weight of the beam too, but there is no mobile load. Determine the height of the beam and the tensile reinforcement, the number and diameters, at optimal use of the materials. The section, you can consider it because it's in a brick wall that the width is the same as the brick wall, which is around 200 millimeters. We have to calculate what is the minimum height that we need. Tensile reinforcement, compression reinforcement. Here we only talk about tensile reinforcement, so the compression reinforcement in this case is just equal to the minimum reinforcement, but we will not calculate it in this answer. The diameter of the stirrup is 10 millimeter, and the yield strength, the characteristic value of the yield strength of the steel is 400 megapascal, and the characteristic value of the concrete, the compressive stress, is 25 megapascal. So we have to make a design with optimal use of materials. So we know that this is a strain diagram after loading, that then optimal use, that means the maximum strain in the concrete and the maximum strain in the steel, the reinforcing steel, with the stress diagram that corresponds with this. This is domain 2A, the left border of domain 2A. We know that C is 0.81 and delta G is 0.416. 3.5 and 10 per mil, that's the maximum values. These are the maximum values. And then Xi is X of D. We can find easily with similar triangulars. So it is 0.259. Then zeta, the lever arm, zeta is of course D minus delta Gx z. And you divide it by D, and then you got, of course, 1 minus delta Gc. You can fill in the numbers, and we find 0.892. And rotation equilibrium around the tensile reinforcement gives you the value of 0.187. The design value of the total load is 22 times 1.35. It's only permanent load, there's no mobile load, and it comes to 29.7 kilonewton per meter. The corresponding bending moment in midspan is then equal to 61.5 kilonewton meter. The reduced bending moment at optimal use of materials is 0.187. So this is the equation. In the equation, you have FCD, the design value of the concrete compressive strength, which is alpha CC 0.85 times FCK divided by the material coefficient. The national application document in Belgium puts the alpha CC factor at 0.85. So FCD equals 14.167. You use this equation to find D, the effective depth. We put in the different numbers, take care of the units. The units are Newton and millimeter. That's the most easiest way to do. And then we got 340 millimeters that we need as effective depth. The corresponding reinforcement is then the bending moment divided by the lever arm, divided by the design value of the yield stress of the reinforcement. We know the zeta at optimum use of materials, it's 0.892. So this is easily calculated, and we get 583 square millimeters. Because the width of the beam is small, we only use 2 diameters. So we you can see that 2 diameters of 20 millimeters is 628 square millimeters, which is bigger than AS, so that's okay. For durability, the beam is in an environment of freezing and contact with rain. So it means that you have durability class XC4 and XF1 for the frost and XC4 for contact with the rain. In Belgium, this means that we are in environmental class EE3. The concrete cover comply with this durability request is that the concrete cover must be the maximum of the diameter of reinforcement plus 15 millimeters and 40 millimeters. So in our case, it is 40 millimeters. We check first the width of the beam. The width is 200 and must be bigger than 40, which is the concrete cover, plus the stirrup diameter, times 2, because you have left and right, plus 2 times the diameter 20, and the distance, the clear distance between the two reinforcement bars is 40 millimeters. So it makes 180, so this is okay. And then the total depth of the beam is then D plus the point of gravity of the reinforcement. We put in the numbers and we get 400 millimeters. So you can see that the beam that we need in the brickwork is a beam of width 200 and a height of 400 millimeter with two bars diameter 20 as tensile reinforcement. Note that when you design something at an optimum height, you have often that the width of the beam is half the height of the beam or half the depth of the beam.